สวัสดีค่ะ Good afternoon. Welcome to the webinar. This is the last session for the Gut Health and Feed webinar week from Informa Markets in ASEAN under the livestock vertical. So my name is Rose Chitanwat. I will be the moderator for the session today. As you may see the video that we are focusing on promoting our livestock exhibition. Unfortunately, in the pandemic situation, the exhibition could not be taken place in Malaysia, Philippines, and Vietnam due to the travel restriction and also the mass gathering control by the government. So for the exhibition that will be taken place in Asia under the livestock of Informa Markets will be the Taiwan show, Livestock Taiwan in November, which is ready to welcome you guys in the next 2 months. Now we have our speaker with us. Let me check whether he's on already or not. There is some issue on the technical internet connection. However, I would introduce first on the topic that we have today. It's about data management and artificial intelligence in poultry. So this topic is very new for the Asian market when I go through the slide prepared by Dr. Karlinton. However, it is on his study on the data management and artificial intelligence in poultry nutrition. For the speaker, I have a bit introduced about him. He is Dr. Karlinton Flores. He is the animal science and poultry nutrition Ph.D. candidate of North Carolina State University. So let me check with our speaker that what's going on. Apologize for the technical issue. I'm sorry about my voice is too low. I try to make the mic closer to my mouth, whether it's okay. Thank you for the feedback. Okay. The speaker informed us that in 2 minutes he will be in the session. Okay, so there is some internet problem in North Carolina at the place that he is on. Very thankful for him because this is like I think midnight of of USA. So I will go through a bit on the session that will happening in the near future by Informa Markets. We are going to bring in on the layer sector and aquaculture on the feed, nutrition and management again. The upcoming schedule will be announced soon, probably in next 2 weeks. And for those who are interested to watch the old webinar during this week on the gut health and feed nutrition, may I suggest you to see at the YouTube link or in our social media Facebook for our exhibition. Informa Markets is the largest exhibition organizer in the world, but due to the pandemic situation, we have adopt ourselves to engage the community by bringing everyone together on the digital platform. We are going to have the online exhibition and also the digital platform like this by bringing knowledge, technology, and expertise into the platform for sharing. So I would say that feel free to share the topic that you want to hear. We are going to reach the expert. All right. I'm so happy Dr. Karlinton is here. So Dr. Karlinton, I will give the stage to you. Please start with your data management and artificial intelligence in poultry. The audience is waiting for you. Please, doctor.
Yeah, thank you very much. You know, sometimes I love technologies and sometimes I hate it. So For some reason, my computer just started before, the presentation. But yeah, let's go ahead and start. Let me put my presentation up real quick. Sorry for making you wait, guys. All right, here it is. Can everyone see the presentation?
Yes, doctor. We see very clear on the full screen.
Okay, well, let's start. So let's start with my background first. My undergrad, I did it in Zamorano, Honduras. I study a lot of plants. I grew up in a coffee plantation, actually. But besides studying plants, I also study poultry, and that's why it took me to NC State to do a master's in poultry, and now I'm doing a PhD also in poultry and nutrition, which has given me a lot of tools. And the tools that we're going to talk about today is data management and artificial intelligence. So the outline of this presentation is going to be that first we're going to talk about the human limitations. So we all know that humans have limitations, especially when we handle data and we try to analyze data. Then we're going to talk a little bit about the available technology that is present to us to either collect data or analyze that data. We're going to move on to a special technology that is artificial intelligence, and more specifically, machine learning. And then we're going to talk about poultry gut health and how can we analyze poultry gut health data with artificial intelligence, and why this tool is very important for us. So let's start with the limitations. We're going to start with the Fechner-Weber law, which sounds complicated, but basically it says that we're able to be sensible to some data depending on how big the data it is. And also that we have some neurological limitations as humans when we see some data point. So to make that point across, I'm going to show you two slides, okay, with some chickens in it. Okay, and you're gonna try to figure out which one has more chickens, the left or the right. And we're gonna do it real quick. So on this first slide, which one has more chickens? Really quickly, we can tell that the one on the left has more chickens than the one on the right, because there's 3 versus 5. That's very quick to us. It's very insanely fast for us. But now if we move to the next slide, it becomes more challenging. If we try to do it really quickly, we're gonna get really confused. Most of the times we're gonna get a 50% chance of which one has more chickens. And in this case, the one that has more chickens is on the left. Okay. And the reason why we have this limitation on just with 10 chickens is because when we have 3 versus 5 chickens, there is a 66 difference. So we're very fast to know that difference and noticing. But when we move to the next slide, there's only 1 chicken's difference. So that's a 10% difference. And those subtle differences are very hard for us to understand. Now that we're going to talk about artificial intelligence, we need to understand computers. And in computers, they don't have this limitation of feeling overwhelmed, of feeling like, I don't understand the data, I'm just going to shut down. But there might be some hardware limitations. And this is why computers are perfectly designed to analyze data, especially data like we saw earlier, that is very hard to see a difference for us humans. So let's talk about the available technology to us right now. And the available technology for us right now is either in the sense to collect data and store it and analyze that data, and have the computer power to do it. So there's two ways to the scale. We either collect data or we store that data, have the computer power to analyze that data. So on this graph, really quick, I just want to show, you don't have to see everything here, but I just want to show the Moore's law, which basically states that every 3 years, we double our processing power of computers. So on this graph, on the x-axis, you're gonna see that years, and there was very small increments in power, but now in 2019, we have about less than 20 million transmitter count, meaning that we have more power to our processors. Now, going to the data collection, there's also huge improvements on data collection, and that is pointed very interestingly by Walmart, which is a supermarket chain in the United States, where Walmart receives 1 million customer transactions each hour. So that is just receipts, you know. That data is available to them every hour, just in the form of receipts. And this kind of data is called big data. And I'm pretty sure some of you guys have already heard this term. But this term has involved in it that it has to have high volume, a lot of velocity, and variety. So for example, for Walmart, it has 1 million. That's a huge volume. The velocity is every hour, which is very fast. And the variety is that it's only receipts. They have contain a lot more data. In the biological sciences, like for example, poultry production, we don't have big data, but we have large data sets. And in that case, that larger sets are enough to overwhelm us with information, enough for us to think, I don't know what to do with this data. Some of these large data sets are the omics sciences, which are genomics, proteomics, metabolomics, epigenomics, and transcriptomics. And in some of these sciences, we get some data sets like microbiome, and that is very important for poultry gut health. So this is more on the research side of it, but on the practical side, large data sets can also exist. So for example, in the industry, we can collect data with, for example, sensors, CO2 sensors, ammonia sensors, temperature sensors. We can get some body weights with some automatic scales. We also can have performance data sets or historic performance data sets that are just stored, and we don't know what to do with those data sets. They're so large and go for too long that we just don't know what to do with that. So large data sets can also mean that we can use these data sets that are available in farms. For example, a sensor can take a lecture of a point of data set every 5 minutes. So if you have a year, then you can imagine how much data that one sensor can produce in one chicken house. So like I said, there's a balance of computer power and data production. In this graph, I just want to show the Moore's law and how fast we're producing data. So on the Moore's law, it's a straight line, and that's our computer power, and it's steady. But when we're talking about data production, in this case, DNA sequencing has become so cheap in the last 10, 15 years to the point that we can produce these data sets really quickly and really fast and very cheap. So the computer power is being, or the hardware is actually being overwhelmed. It's not the psychological part of the computer, it might be the hardware part of it. So now the idea to it is, how do I analyze this data so we have computer power too? So going back to our slide about limitations, yeah, computers don't get overwhelmed by psychological, effects, but there might be some hardware limitations. We might have so much data. And that's why we need to analyze the data with certain softwares or in some mathematical methods. The first method that pops in our mind to analyze data, it is statistics. Statistics has been used for a long time to run data, and it's a great tool. But one of the limitations of statistics is that it has the curse of dimensionality. And this is a very fancy term, but basically what it says is that if you're going to ask the statistics 10,000 questions, then you need to have 10,000 observations or replicates to create a statistical model. So I'll put this example here because with microbiome or other data sets, we have 10,000 organisms, 50,000 organisms. So we will need 50,000, 10,000 replicates, observations, and that is not practical or cost effective. And you might ask me, well, we run statistics in bioinformatics. Yes, some of those models have been run lately, but the issue with them is that if you want to use a normal p-value, most of the time people use the performan method, which is the standard 0.05 divided by amount of questions, 10,000. And you can imagine if I do that division, then it's going to be really hard to find significant difference. And in bioinformatics, we use other methods that are just a band-aid. They're not real solutions to the problem to having a lot of questions, like, for example, a microbiome test. And these are just some corrections that we try to do with statistics that are viable right now, but we have our disposition available technology that is more powerful. And that technology is artificial intelligence. Artificial intelligence, we might want to know how to define it because we have heard a lot about it. You heard about it, in the sense of the Terminator, or like, it's a bad tool, or like it's a tool that is only used for like big companies and stuff like that. But basically, artificial intelligence, it's just any system that controls or acts without any human input. So very easy to understand will be your thermostat in your AC system, or your thermostat in your chicken house. You set it to a certain degree, and without human input, it will turn on or will turn off depending on the temperature. More complicated than artificial intelligence, we have machine learning. Machine learning is part of artificial intelligence. But in this case, not only is having an action without human input between some characteristics, but the computer is trying to learn from data, and that's what we want it to do. So basically what it does is it has all the data, and then with that data, it breaks it down, it learns from it with some mathematical algorithms. This is all basic math. And then the goal from learning from that data is to predict something. And there's two types of learning. There's the supervised, where we know the outcome. We know that if we have 2 plus 2, we have 4. But then we also have unsupervised, where we just give all this data to the machine, and the machine will have to let us know what it can find. So to put it simple, in a very simple example, we have all this data that we feel overwhelmed with, which are all these little rocks from river. We can organize this data from, the shape, the color, the size, the weight. We don't know what to do with it. It's a lot of rocks there. But for some reason, we know that all these rocks yield sand and all the rocks. So we give that information to the machine. That is a supervised machine learning. We know the outcome. We know that these rocks, outcome, this sand, and these rocks. So the machine can learn that way. But the other way that the machine can learn is just by putting all the rocks and ask him, well, what do you see there? What is the pattern that you see there? So those are the two ways that the machine can learn. Now let's talk about data mining, which is another term that we hear about with artificial intelligence and machine learning. And basically, I'm going to explain it real fast, really simple, is looking for patterns in the data. And I put this owl in this picture here because that's actually a pretty good book to read to learn about machine learning and data mining using a tool that we're going to talk later. But basically, just think that tree is the data set. And then there's a pattern in there. There's something that is looking at you that is important, but you cannot see it in the data. But we cannot see it because of our humans' limitations, but it's staring at us. So data mining does that. It's telling you, hey, look, in this tree, not only you have a tree, you have an owl, and it's looking at you, and it's very important for you to look at it. So that's what data mining is. In the whole data collection, there's a pattern inside that you need to look at, and that is very important. And this is done by a human user after the computer has done some work. So now that we have an idea of machine learning, the definition of machine learning, now we have to ask ourselves, well, how do I use it? How do I eat it? How do I cook it? Do I put it in my radio? Do I, put it in my Xbox? How do I use it? And the way that I learned so far is two ways. The first one is using a PC or a computer, having programming code. And coding, it can be done with Python, which is a language. There's a lot of different languages. We usually use Anaconda distribution package with a TensorFlow software package. Those packages are basically the packages that give you the algorithm, the math. This is the very complicated way, and I personally don't use it because it requires a lot of training on coding. There's another way though. The other way that you can use machine learning is through softwares. Just like statistics, it has SAS, JUMP, or R, or other statistics softwares. Machine learning also has some softwares out there. And these are just examples that you can check later on your own time. And I don't use this neither. The one that I use is Weka. And the reason that I use it is because it's free for university. And right now I'm in a university, so it's free for me. But in the industry, like industry people, they'll have to pay for it. But this is a great software. It's a great resource. It was developed by the University of Waikato in New Zealand in 1993. So they already have 27 years of experience doing this software, and there's a lot of information out there. So that book that I showed you earlier with the owl, data mining, is based on this program. There's a lot of information in YouTube. And like I said, if you want to use it, you might want to get in contact with them. They're pretty good. And they are named after a bird. So I think that's cool too. So now that we learned a little bit about artificial intelligence, machine learning, data mining, what software to use, where to use it in our PCs as a program, then we can think about the data that we're gonna input into those programs. Some of the data that comes to mind is environmental data. Like I said, temperature, CO2, ammonia, nutritional data, nutrient composition of the diet, stress, genetics, microbiome. And since this is a gut health related, and this is what I work too, we're gonna use the microbiome example. This is a great example because microbiome, like I said, has a lot of variables, a lot of questions, a lot of species, a lot of bacteria or other, microorganisms. And we want to know how the data affects, how those microorganisms affect performance, body weight, feed intake, cost. So the idea is to introduce microbiome data to be able to predict for body weight, feed intake, cost, something practical for the industry. But you might have other questions, and that's valid too. So any question that you have, you might use this kind of data to predict. And this is why we use machine learning, because this is an example of a data set, just a glimpse, a little, screenshot. It looks very beautiful, we used to joke before machine learning that we don't know what to do with this data set. So one of my roommates, we used to just put it on the wall to look at it because it's beautiful. But other than that, it's very hard to interpret. It's very hard to take a message home of what's going on there, and all of those different colors of bacteria and different birds, so a simple glance, like I said, you feel overwhelmed. You don't know what to do. And that's why we use machine learning. So what do we do? What do we do with this kind of data? If you want to quantify and summarize, then you use statistics. And if you want to predict and find patterns, then you use machine learning. And I think that's a key message to take too, is that statistics is not irrelevant. Just because we're using this new tool called machine learning, statistics has its own benefits. Like I said, quantify and summarize, and it can use both with machine learning. I actually use both in my research with microbiome. And the interesting thing about both of them is that they both use math. So we're gonna talk a little bit about it. It's a little bit, boring, but we need to know it. So the math that I'm talking about in machine learning, just like in statistics, where we have linear regression, quadratic models, where we have, ANOVAs, t-tests, c-tests, all these things. In machine learning, we have support vector machines, which is a very interesting algorithm, because in this data, in this image, you can see that there's red dots and green dots, and it's very messy. You don't know what to do with it. But the algorithm makes it in a way that it can create a straight line through it, and that's the answer that it gives you. Now, neural networks are the ones that are most famous and popular about machine learning and artificial intelligence, because it mimics the brain. It basically has some kind of nodes that looks like neurons in your brain. But basically, what it does is that you have an input layer, which is your data. And then it has some little nodes that connects that to the outcome, to the prediction. And if the machine cannot make it to work, then it goes back and change those yellow dots, which is the connections, and it changes the weights until it has a nice prediction for you. It's a nice tool to work with. And then lastly, you have decision trees, where you have, decisions, yes, no, you have your leaf, your nodes, your branches. And these are just 3 algorithms. There's hundreds of algorithms in machine learning that you can use. So there's a lot of math that you can use, but these are just 3, the main ones that I use in my research, and I use all of them, So you might be wondering, well, how do the machine learns? How do we know that it's learning? So basically what the machine does is, going back to our chickens example, you got 10 chickens, right? 10 samples from microbiome. And then from those 10 samples, the machine will learn from 7 of them, will make a model, will train the model, make a model that will predict. And then from that model, it's going to test from the same data set on other 3 chickens to validate that model. And it does it multiple times. It's just not once. It does it with different parts of the data. But that's how basically the machine learns, and you validate that it learns. So let's put it all together and see how we can apply this. Basically, we have the sample, which is that chicken over there. We can take samples, like I said, on microbiome, or pH, or whatever you want to do. You can take any data set that you want that is, complicated and large. That data set then goes to be analyzed, and that's where you have our, picture there with the different colors and different bacteria. That's the most important part of it. You need to know your data. You need to know to classify it, to filter it, to know that it's valid, that has been processed correctly, that you have really good data. Because if you have bad data into the model, you're gonna have a bad model at the end. So if you get something from this presentation, is that even if you run statistics or machine learning, you need to know your data, and that you need to figure out if your data is correct, that your data is reliable, and that is filtered. Now that we have the data, then we go to our friend, the software, in this case Weka, and with that software, we can apply the algorithms. In this case, support vector machine. We just don't do it once; we do it multiple times, and we do it eliminating variables to reduce the variance. So, for example, we're gonna have a graph like this, and it might look intimidating at first, but this graph is pretty simple. On the x-axis, you're gonna see the number of variables. So we went from 29 variables to just one variable in the model. And in the y-axis, or the vertical one, you're gonna see the efficiency of the model in R squared. So the green line is basically the models that we constructed, all of them. So we created 29 models. And the models that were the most efficient were models when we have 5, 4, 3 variables. And this is trying to predict body weight in birds. So we're trying to predict if these variables can predict for us if we're gonna have a bird with objective body weight or low body weight. So there's two options. You either choose objective or low. That red line basically means that if you were to choose one of them, just pick one, guess, you have around 50% chance. It's like tossing a coin, right? If this graph is not 50%, 100%, 50% straight, because we only run it 10 times randomized. But if we have infinite amount of replicates, then it'll be 50%. So our model, the green line, has learned more than random chance than just giving the chance of picking, oh, this is the correct one. So that's a very valuable model when you're able to beat random chance. So with this model, the best R squared that we could apply was 87.5% of the variation explained or correctly classified, that we have correct, with 3 marked organisms. And this is just an example. So now that we know that, and that we can predict with 87.5% correctly, then it's when we do the data mine. That's when we do the data mine. And we ask ourselves, well, what are those organisms? Why are they important? Is there any literature about those microbes? Is there any pattern between them? Do they work together? Are they pathogens? Are there good microbes, symbiotic microbes? How do they interact with the gut? How do they interact with feed? Can we change them? Can we feed probiotics, prebiotics? Can we, so that's when data mining comes in, and you're trying to figure out why those 3 microbes are selected. And just almost finalizing the presentation, just want to make sure that you understand that not only we can use microbiome datasets, we can actually join the microbiome datasets, the gut health datasets, with feed milling datasets. So we can combine both. We can combine both of them with hatcheries, breeders, production. The more data you have, the better. And then at the end, in your whole system, if you have this, then you can see, oh, this is the reason why we have a low body weight, low feed intake, low cost. It's because we data mine for this, and we can put all this information there. So machine learning is not only valuable for gut health, but also valuable to see your whole operation, because the more variables, the more questions you have, the better. So let's say that we use the microbiome and the feed meal data sets to predict for body weight, feed intake, or cost. Then this is just a hypothetical example. Maybe the data is going to tell the machine learning is going to tell us, while data mining, that you have a salmonella problem, and that is creating pathogenesis. And that's why you have a lower body weight, low feed intake, or high cost. And that maybe your pellet quality is also low, so that's why you need to change those things. And that to me is the importance of machine learning. Being able to, in a huge amount of questions, being able to track a couple of them and saying, this is why you need to get better. This is why you need to pay attention. This is your owl in your tree that is looking at you, but you cannot look at it. You cannot see it without machine learning and data mining. So a take-home message while finalizing the presentation is that humans get really fast overwhelmed with data. Like I said, we can barely handle the difference between 9 and 10 chickens. So we need some tools. And those tools have been generated, by an advance in technology. That technology either help us to generate data or to analyze it. And it's our responsibility to learn from both of them so we can improve our production systems. One of the issues that with that amount of data, a lot of data statistics not might be up to the task to analyze it, but it's still important. It's still important to quantify and summarize it. And to end the presentation, machine learning allows us to predict and explore data patterns that otherwise we cannot be able to see. And with that, I'll finish my presentation. And if you have any questions, let me know.
All right, Dr. Karlinton, thank you very much for the presentation. I think it is a very advanced on what you have shared to us. So I think we have only like 3-4 questions because of this is very new to many sectors. Apart from the system we are using automate in the farm or in the feed mill, this is on the prediction side. So the audience want you to explain a bit more on, can you clarify what is accuracy of the information if you use the AI system and when we adopt to use the CO2 sensor, there will be like any interfere on that?
Yeah, can you repeat the question, please?
The question is, can you clarify what is the accuracy of the information when we adopt the CO2 sensor in the farming, I think?
Oh, yeah. So in some part of my presentation, I talk about the data and how it's important to know your data. When working with sensors, I think it's the way to go in the future, because sensors are not humans who are prone to errors. So actually, when you work with sensors, the tendency is that you have a more accurate model, And I didn't talk that much about the model and how you verify that the model is working correctly, but there's methods to do that, and that you are sure that the model is giving you a right information. This was just like a very, very simple presentation. But like I said, if you want to know that the model is accurate, you are able to do that. So it's not like you're not able to do that.
Yeah, so meaning to say like the sensor technology will come to the farm production in the farming management and production soon. However, in using the data management in that, this
Exactly.
CO2 sensor will be one of the factor to interfere in that and how to set the variable factor on that, right?
Yeah. So yeah, that's very important too. So when you're trying to analyze these data sets, you need to set everything accordingly so you can analyze it. But yeah, one of the issues that I have is that, you know, it's nice to have these data sets in the sensors, uh, to have it present. But when you look at the sensor data, if it's recorded every 5 minutes, if you're a human, then you get overwhelmed really fast. You just read 10 lines, and then you're like, I don't know what to do with this data. And that's why tools like machine learning are important, because then you organize your sensor data, and then you input that data to the machine learning so it can tell you this is what's going on in your farm.
Yeah. So the next question would be like your idea from your expertise and learning from your study is what is the future of the intelligence data management you see it will implement in the poultry sector, and how you see the Asian like us, how far we are from there to adopt that technology?
So um, that's a great question. You know, the future for this technology is again with sensors, because right now, let's say that I took that sample from microbiome in a bird of 3 weeks of age or 2 weeks of age, and I just did it once, you know, and trying to predict some body weight or feed intake. But with sensors, it gives us information all the time. So you apply a machine learning algorithm. So every time that the data comes into it, it can learn again and again and again. So the more data that it has, the more it gets at learning, and the more you have accuracy. And that is called not machine learning. It's called artificial intelligence. It's called deep learning, because the machine is learning every time, you know. So every 5 minutes, if you give it an input, every 5 minutes the machine will learn, you know. So that's the future.
So it's not the lock system or set the ceiling in a system, but it is already adopted into the artificial intelligence, like the robot
Exactly.
learning like human
Learning.
and keep recording in their memory, right?
Exactly.
So very interesting.
Yeah.
I am very impressed on now what we adopting into the poultry sector. This question is quite long. Please stay with me, doctor. I try to make it very clear
Sure.
to you. The audience asks, climate control in the evaporative system or closed house is already using numerous inputs to regulate on an optimal environment for growing the broiler. Okay. Most problems, however, happen due to health. It is about health of broiler. The question is, how can AI support the farmer to keep a close eye on the health status of the flock without calling a vet?
Exactly. And that's wonderful. It's wonderful that you have houses that has a lot of inputs, because those inputs are the ones that we need to put in the machine. And it's a great question because it's a lot about prevention instead of calling the vet, you know, to cure the flock. Uh, so with those inputs, not only you can control the growth of the bird, but you can see if at any point of the growth of the bird there's a stress. And most of the times, for example, and I think Grayson Walker from NC State also talked in this webinar, and JT. There's a stress, and that stress causes necrotic enteritis. That stress causes colibacillosis. That stress causes a change in the system of the gut of the bird that will make it go into a disease. So with machine learning, we get those inputs from these kind of houses that are very technological, and it will let us know you need to keep an eye really close on your temperature or your humidity. This is an example, So whenever you know that your humidity reaches this point, it's very probable that you're gonna go necrotic enteritis. Or when your temperature reaches this amount with humidity this way, it's pretty sure that in your situation, you're gonna get necrotic enteritis. So that's the prediction power of machine learning, So for this person, the question is, how do I know if I get disease? You collect the data, the inputs, and then you say, okay, with these inputs, I got necrotic enteritis. And then next time, machine learning is going to let you know, okay, you need to look for this, this, and this, and this for able to predict for necrotic enteritis, So body weight for him might not be interesting to ask the machine learning, but what is interesting is to ask if a flock is going to have necrotic enteritis.
So it's like the artificial intelligence now playing the role of memorizing, and even in the first stage, if any farm using after they do post-mortem, can check back into the record, and in the future probably they can
predict.
Even get alarm that this is going to cause the same problem. All right.
Exactly. So yeah, the data you collect is from flocks that already happened,
Yep.
The disease already happened, you already have the inputs, there's nothing you can do about those flocks. But once you have implemented machine learning, then you can be like, okay, now I know when this is going to happen, And that's the beautiful thing about machine learning. I talk about body weight, feed intake, cost, but for this person, the question of importance might be disease. So you can ask any question, and you can input any kind of data that is good data, not bad data, but good data,
Yeah.
And then ask the questions.
So the next question come to me is like, are you starting to work with any breeder company, because they start from the genetic itself?
Actually, yeah, I have run some projects with some breeder companies,
okay.
but right now I'm still working with them, so
yeah,
cannot talk
great
that much
news.
about it.
Great news for
Yeah.
us, because not many breeding companies, so we can get benefit from that. So I go to the next two questions, but next question, I apologize to the audience. I myself don't know the abbreviation, but I try my best. The question is, why do you use R2, not AIC or BIC?
Yeah, that's a great question. And I think what you mean by AIC is archaicus, and BIC is I don't remember what BIC is. One of the biggest thing with machine learning, when you start working with machine learning, is that you might need to forget all your statistics work in courses because it works totally different. The output that it gives you is very different. And the closest one that we have chosen is R squared. That's the closest that it can relate to statistics, which is, the correlation of correctly classified or the variability that the model can explain. But for example, in machine learning, there's no p-values, and that's something that I forgot about my presentation to explain to you guys. There's no p-values, so the way that it works is different. It still accounts for error. It still accounts for R squared. It still accounts for area under the rock curve. It still accounts for the kappa statistic. It accounts for a lot of things. It's math, and you can account for error. You can account for it, but reading it is a little bit different than statistics. So that's the only difference.
All right, I think we passed the time already, Doctor. We are going to have last question for you. Apologize for the overtime. So the last question is the quality and type of data from your presentations seems to be the driving factor to get good
Mhm.
prediction, and also the model to be used, that's quite good. So the question is like, do we need any specialized machine or equipment for that purpose?
So the answer to that is preferably yes. Preferably if you have sensors, like I said, that's the future. Sensors, temperature, CO2, and there might be sensors that have not been invented yet that we can use in the future. You know, because then we don't have human error. Because we don't have someone who wrote something and they either write it down bad or they wrote it down, a typo where they're supposed to write something else, but they wrote. So all those things are something that uh, improve the error of the model. If you don't have that type of data, then your work is to filter the good data. Be able to say, this farm, I trust the crew members that they're taking good data, or I personally took the data for that, or I trained these guys to take the data correctly, or have a system where you can collect data correctly. So your task then is to filter, to take rid of outliers, to take rid of blank data, to be able to manage that data in a correct way.
All right, Dr. Karlinton, thank you very much for your today presentation. It's very new and open future of the poultry industry with the AI already. I hope I could get you back with the new research data on this again. Okay, thank
Yeah,
you very
sure.
much, ขอบคุณค่ะ and thank
No,
you to the
thank you.
audience that with us today. This is the last session for this week of the gut health and feed webinar week. So we are going to bring the new sector into the digital platform of the livestock series by Informa Markets. I am Rose Chitanwat. I'm going to see you again in next few weeks. Thank you very much and have a good day.